will start with Stef, Market Access Manager at Septentrio. Just see if my mouse works. Yes, it works. So very briefly, who is Septentrio? Septentrio is a spin-off of IMEC. It's a research and manufacturing institute in Belgium. Previously worked a lot for the ESA. Actually, that's where we started, more on the scientific side of GNSS, and moved actually the past, especially 15 years. The company is now existing for 20 years, slowly towards the industrial side of many applications, meaning that the knowledge which we have and still do actually act upon project ESA, knowledge that we have from there, we put in industrial applications, which of course brings a lot of benefits for the customer side. We are represented all over the world, actually, not only with sales offices, but also with technical support, so technical local support, so also in China, Japan, and South Korea, for example. Resellers, of course, all across, which could also support locally. And as said, serving several industrial markets. And basically, we have 4 pillars: accuracy, reliability, availability, and security. Those are actually the biggest credos of our brand. Then if we look at what we do is we build up everything ourselves. So we don't assembly only a GNSS receiver, but we build the chipset, we build measurement and positioning engines. We, from there, of course, existing products, so GNSS modules, OEM boards, but also packaged receivers. More and more use package receivers in the marine side, of course, because of the ruggedness. But towards integrators, we can also provide module level components. So we see ourselves more as a technology provider rather than a solution provider fully. You saw the previous presentation of Anapsys. They, for example, use our receivers and build an end product. They integrate it, so they are much more niche on a certain level of market. So we are represented all over the place, agriculture with guidance and steering systems, a lot of autonomous systems, of course, also in the mining and the logistics fields, as you see also on the port side. As Manu also mentioned on the OSNMEA, kind of integrity and anti-spoofing signal knowledge, which is fairly dedicated actually towards the autonomous side, especially in integrity, of course. This is where our core business lies. The offshore dredging side, so I only picked the marine pictures over here, of course, because that's a little bit on where we dive into right now. Here you see is a few global customers, just a little subset of the customers we have worldwide. And if we look at our portfolio, then again, we have the modules, we have the boards, we have the GNSS INS, so the combination of GNSS core technology, combine it with inertial technology, and you will get a lot of more capabilities and actually applicabilities on the application side. And we have the house receivers, all packages, the single, the dual, the GNSS version and a dual version, and also the marine side of dual antennas and marine receivers, which are specifically built for the marine side. And then we have the smart antennas, and this is actually the big portfolio. I'm going to zoom in a little bit on the interference and the jamming side and the spoofing side of things. So what I want to show with this is actually that the technology inside the receiver really matters in a sense of accuracy and reliability in general. So meaning that we have built all kinds of technologies to, for example, overcome tracking robustness, or actually to make the robustness better on the tracking side. For example, withstanding vibrations, a really good multipath estimation and mitigation. Also, we are known in the scientific market for a very good ionospheric monitoring. Nowadays, we are a bit on the low side, of course, of the scintillation, but it's upcoming again, the upcoming years, actually, it's growing again. And you also see the need actually on the industrial side of applications because of a certain fear on that side. Of course, the PVT engine, it's very important inside the receiver itself. And then we focus a little bit on the AIM+, so the interference side of the receiver. So, well, this is of course typical interference. It's often unintentionally. Actually, well, probably many of you know a simple analog video transmission from a webcam can already disrupt a lot of signals. That's also why more signals is often a good idea for these integrations. Very basic. What is spoofing? Spoofing is of course the simulating actually the signal and sending fake messages in there. And you can do a lot of bad stuff with that, especially on the autonomous side, because the data can still be received, but the transmission is not the right one. What is jamming? It's totally disrupting the signal, of course. And jamming you see a lot actually, and you see more and more. Whether it's a trucker which has a simple car jammer to avoid toll or paying roads, all kinds of people use simple jammers for all kinds of reasons, and actually they disrupt all kinds of signals, right? So we have the radio TV, which is the most common case of interface. We see it in the marine, especially on the offshore side or the nearshore side, I would say. Navigation beacons, more for the airfields, I would say. UAV self-interference, it's also more for the UAV side, but know that your Inmarsat or Iridium can also influence the UAV drone you use on a ship, for example, or on a vessel. Intentional jammers, you see them a lot. They're very cheap nowadays. And then, of course, the marine communications itself, they disrupt a lot of signals on the satellite side, on the receiver side. So you need to overcome that, and you need to have a decent receiver to overcome that. So what happens here, for example, the Shelter Island, you see a simple car jammer, only 10 milliwatts. It's cost, I don't know, around $30 maybe. It's very cheap. What happens with a regular GPS, and this is actually a fairly high-end unit. What happens with that? Disrupt this call. What happens with that is that you see a massive interference actually, and in the red zone you couldn't do anything actually with the receiver side. On the blue zone, it also massively disrupts on a meter level accuracy. What we would say is you cannot do any dredging or surfing over there anymore. Let me click on further. A Septentrio receiver should tackle all these problems. So you see almost nothing here coming from the tests. And also if we look at the continuous wideband jammers, then you see, well, big red spots actually on several competitive receivers. And every time when we do these tests, we are still amazed that some receivers cannot pick it up or at least filter it out the signal. And then if we look at the Septentrio receiver again, then you see much less interference and the dot is much smaller inside the field. Interference can also affect the PPP side of things, of course. PPP commonly used to obtain your better precision in general. We use MarineStar, provides a sub-decimeter accuracy and also the L-band delivery with an N-trip fallback. Well, a lot of interference is still also on these correction signals by Iridium and Inmarsat. And actually what we did is we built a dedicated L-band demodulator inside our receiver. So it's actually a tracking part of the correction signals. And it tracks actually, it's LBR tracking, and it's not close to the receiver. So it's not inside the receiver, but it's a separate component from the receiver, which allows us to have a better, cleaner signal and more safe. And eventually we have almost none interference anymore from the Iridium and the Inmarsat. How does it look like? For example, the marine receiver, which we have here, it has everything stacked on there what you need. So it's a sort of a full solution. This is one of our solution products from the technology perspective, I would say, but heavily used in dredging and navigation for marine. For example, when you enter the narrow ports, right, they use a secondary GNSS receiver to steer certain things. So it's marine ready in that sense, with additional LBR tracking in there. And then if we look at the spoofing side, spoofing it doesn't seem much, but it's very cheap and simple to make one, which is a little bit scary in a sense, especially again, if we look at the autonomous side of things. It only needs a laptop with some software on there. You can buy it on Amazon, Hack RF, for example, for $150, and you can start spoofing. So software is often open source available. So it's very easy. I just want to say that it's very easy to spoof. And I like actually this example always of this case. So probably most of you know this. I believe it's still not fully, the investigation is still not fully concluded, but what is happening here is a lot of signals spoofing around. And yeah, what can happen then is when the navigation is not right, it bumps against the docks, which is of course very scary if you think of all the new autonomous applications coming up. So better to have a good anti-jamming and anti-spoofing inside your receiver than, for example, going a little bit more low cost on the industrial side of GNSS receiver. You see this happening a lot all over the place. So again, Septentrio has some technologies built in. We call them AIM+, for example, for intentional spoofing and jamming interferences. We could also use this online. So we have a full web interface towards our receivers, which is very handy, especially if you want to configure or monitor certain things from a distant side, especially now with COVID, right? When your support is not online on the same place or at site on the same place, you can enter a certain receiver online. We have all kinds of dedicated technologies in there to make it more robust and more stable. And that's pretty much what I wanted to say for now. It's very short, but we're on time constraints, so I leave it for the Q&A now. And when you have any questions, let us know, and feel free to reach out when you want to try one of our technology products.